All right. So, good evening, everyone. Myself, Hanuman. Okay, and I'm basically a founder and owner of Infotech. So here in this session, right, I have Ram over here as a presenter for this particular session. So, what you're gonna expect from this session is, and why we thought about this is, um, basically there were multiple requests that were coming in regarding and these are mainly students who are currently entering the fourth year of the curriculum, currently pursuing their career in the data, and wanna move towards cloud services. So that's where we thought like to make a step towards the careers of the students, and that's where we thought like to have some kind of free webinars where the candidates can register themselves for free, and that's how they can enroll. And throughout this session, because see, in the market, you can generally get lots of theoretical knowledge, right? Lots of examples. But what you miss is like, how do these things actually work in the companies, in the projects, right? And that's where we came with this idea. Like, and this is gonna be occurring maybe weekly or bi-weekly, depending on the time slots and the availability. And with that, like we are going to have our first webinar on the web application with the containerization of the ECS Fargate, which Ram is going to lead. So yeah, apart from that, we don't have anything else. We are going to directly start with the session. What you can expect from this session is a real-time learning and real-time experience on the project. Apart from that, if you have any kind of questions or if you have any kind of queries, right, there will be a particular slot in that you will be having privilege to ask any kind of questions, and by the meantime, you just sit on your back and just enjoy the session. And after that, we are going to have the Q&A round as well, where we are going to come with a bit of quiz questions too. So yeah, nothing much. Over to you, Ram, now.
Thank you, sir. Is my screen visible?
Yep, they can't unmute. So yeah, I'm going to give on the behalf. But in case if
Thank
you're
you,
not
sir.
able to see, guys, just let us know in the chat.
Okay. So, hi everyone. I'm Ram, and welcome to this mini project series. Okay. So today I will be your cloud and DevOps guy, and I think like we'll be having a great time learning like some AWS services and how the deployment aspects work through CI/CD pipeline. So let's quickly start with this. So here we discuss the session outline. So firstly, we'll be understanding the project architecture, like how we'll be deploying and like what's the flow of this project. Then we'll discuss about these key terminologies which is required to understand the project architecture, which can be the different AWS services, Docker, and GitHub. Then we'll jump towards the project implementation side, which we'll be doing on the console, and we'll be using VS Code also. Then we'll be having a quiz round where we'll discuss like what you've learned throughout the session. And at last, we'll be having a QA also for you. So if you have doubts, you can just note it down, and at last we'll just answer to your questions. Okay. So let's come to the architecture part. So this is the architecture that we are going to deploy today. Okay. But before I explain you the architecture, there are some key terminologies that you need to understand first. Okay. So we'll come back to the architecture later. First, let's understand this key terminology. So first thing is GitHub. I hope like you are all aware of the GitHub, but let me just quickly summarize it for you. GitHub is a place where we can store our code remotely. Okay. And I say remotely, it's like it's sort of cloud storage. Like it's not stored on your local system. You have your code files in GitHub, and here in the example also, like if you can see, like this is your local environment where we generally develop the code. So you commit it, and the commit is inside your staging area, which can be a local repository. After that, once you have finalized it, you just put it to your GitHub. So it's more sort of like it enables you to collaborate with others, and it also enables like to have your public and private repository. So let's say like if you're working on a collaboration project, so you can go for the public repository because it's visible for everyone. This is the most common thing that you can see in the open source projects, let's say the Kubernetes and Linux, because their repositories are open source. But when we talk about an organization, let's companies developing their own product, so they opt for private repositories. So that's what we are going to do today. Like we'll be having a private repositories, because for private repositories we need authentication also. So that is added step which I'm going to tell you, like how you can implement private repositories. because most of the times when you'll be working in a company, they'll be using a private repositories only. Okay. So next thing, if we come is like it's AWS IAM. Now, if I talk about AWS IAM, it's the core of AWS. You cannot work without understanding the AWS IAM because everything you access inside the console, you need to provide particular permissions or rules via AWS IAM. So here, if I say like who can access what, so let's say users, or it can be either services also, can access this particular AWS resources. So if I give you a small example, let's say I've created an IAM user inside my account, and I want to give him a particular permission just to audit my CloudWatch logs and of like let's say S3 bucket. So except from that S3 bucket and CloudWatch logs, he won't be able to access any other resources inside my account because he's restricted by those permissions. But it's not limited to the users only. When I talk about IAM rules, it is generally assigned to your services also. Let's say your one AWS service needs to talk to another. If I take example, let's say we have an EC2 instance and we have some files which is stored inside S3. Now, if I'm EC2 instance needs to talk to that S3 bucket, I need to provide an instance profile role. So that's how like the communication and like access permission work inside the IAM. Now, next service will be the CodeBuild. Now, CodeBuild is more sort of a continuous integration service, and it's like similar to Jenkins because that's a more common word that you have heard inside the DevOps terminologies. So what CodeBuild is doing, like once you have your code inside your version control repository, so after that, like it is full in the CodeBuild, it will build your application. When I say build, it means like it will compile your source code. It will run tests based on like, let's say like you've created a unit test or like there are some common tools also, let's say to find the vulnerability inside your codes, which is one of the common is SonarQube. So once like this build and test is completed, it will package your application, that dependencies files, and it will push it as an artifact inside S3 bucket. So, and one more thing, like it's a common practice to enable logs on the code build side file because let's say like if you have encountered any errors, right? So in that case, like the logs will help you a lot because if you're a DevOps guy, the first thing you need to check is the logs, right? So that's the thing. So another service we'll be seeing is the AWS code pipeline. So once we have our code stored in the cloud, we have our build ready, we have our deploy stage ready, but how to integrate them inside one single pipeline, right? So for this, we use a code pipeline, which will integrate your source control, where your code is stored. Next, where you're building your code, it can be the code build or Jenkins. Now, third stage is like where you need to deploy that build package. So for deployment part, we'll be seeing ECS today. Okay. So this is the basic architecture of the code pipeline. We have a code commit here. You can just take an example of GitHub or code commit or any other Git hosting services. Then we have code build, which will be building and testing your code. Once it's created the artifact, we will directly deploy it to the code deploy. Now there is an added step, which is known as manual approval, which is a common practice when we are deploying it to production environment. But it's like for today, like we'll just skip this step because we are just having a test environment only. Now, here you can see this SNS service also and this IAM user also. So once this manual approval has been triggered, so via SNS, you can just directly give a notification service. Basically, like SNS is more sort of permission providing service, but again, like it's currently out of scope. So we'll see this service later in the future courses. So if I talk about the next service is the Docker, ECS, and ECR. So before I move towards the ECS and ECR service, let's talk about the Docker. So basically, Docker is a containerization platform where you can run containers, right? So what are containers? Containers are lightweight machines where you can run your application independent of the that environment where it's running. So what ECS is doing, ECS is managing all that containers because when you're running your application, right, it can have different APIs, it can have different static files, right? So it cannot be just one container. Now, to manage all these containers, let's say like when we talk about a company like who is running their own product, even it's a small scale also, they have minimum sort of like 25 to 50 containers, even for a small application. Now, to manage all that applications, we need ECS service. It's similar to more sort of like Kubernetes, but Kubernetes is more sort of open source API. ECS is more sort of managed service, which is provided by the AWS to orchestrate and manage your container services. Now, what containers are doing, like it's a basically type machine only, as I already told you. But to deploy a container, you need a template because, like, how will you deploy a container if you don't have any manual instruction ready? Like, what dependencies you need to install and what is the like operating system you need inside that your container. So for that, we create image. So here we have ECR. Basically, ECR is a container registry where you can create your own images inside your local environment also and push it inside your container registry. So it can be stored and can be accessed by different pipelines. Let's say like if you need to share also. So that's where we use Elastic Container Registry. It can have either private registry or like public registry also. Okay. So once we have just created our image and push it inside the ECR, then we comes toward the ECS service. So what ECS service will doing? ECS service will be pulling your image from the ECR and it will creating container out of it. Now your image will be consisting your application also and all the environment related dependencies also inside that image. So based on that image, your container will be created and a group of container can be accessed like via ingress load balancer to make your application accessible to the public internet. So let's come back to our architecture. Just give me a sec. So now if we talk about our architecture here, so here you can see like firstly we have GitHub, which will be our source code part today, where we'll be storing our source code today. So after that, once we have stored our code, we'll need a CI integration where we'll be building our code. So what this code will be doing, once we have pushed our changes inside of GitHub, so it will be pulling that changes from your GitHub. It will building that image and it will push that Docker image to Amazon ECR. Once we have the image inside the ECR, the code pipeline will automatically trigger our code deploy script, which will be deploying our image to Elastic Container Services. Now, if I talk about like how we'll be creating the services, so we already have the GitHub ready where our code is stored. Next, we'll be creating the CodeBuild project. Okay. So along with the CodeBuild project, we also create a ECR first. Okay. So we'll be referencing the ECR to CodeBuild so that it can push our image to ECR. Then we'll be stabilizing a Elastic Container Service. For that, we'll need to create a cluster. So you can assume like this is a cluster. Inside the cluster, there are certain services. Let's say you have two APIs. So for that two APIs, you will create two separate services. Inside services, you'll be having a task definition. Task definition is more sort of like you can create a template and you can just mention like this is how you're going to reference your image and these are the port numbers on where your container should be accessible. And based on that task definition, we'll be deploying set of tasks which will be having a group of containers based on it. So yeah, I think that's pretty much for the architecture side. Now, if you have any questions regarding the architecture and regarding the services, you can just paste in the chat so I can just reply you. Then we'll directly jump towards the implementation side.
So meanwhile, any questions from anybody with regards to whatever the words that you've heard so far, like GitHub, containers, registries, clusters. If you have any questions, let us know in the comments. Or just raise your hand so that we can unmute you. All right, not hearing from anyone. Okay, Shivesh is having one question. Okay. All right, Shivesh, go for it.
Yeah. So, hello. Good evening, sir.
Good evening.
And I want to ask about that Fargate thing.
Okay. So let me answer you, Shivesh. Basically, like when we deploy cluster, we have two type of launch types. Either we can create a cluster based on Amazon EC2 instances, which will be a virtual machines. And for that, let's say like you need to scale to up to multiple containers, right? So you need to set up a scaling thing for the EC2 instances, which will scale based on your workload. But if I talk about the Fargate thing, Fargate is another option which is provided by the ECS service. And the benefit of using Fargate is basically it's serverless. It can automatically scale based on your needs. You don't need to have a EC2 instance in the pre-reserve, or don't need to think about the scaling part. So for the today's webinar, we'll be going ahead with the Fargate thing. Okay. I hope like I have answered your question.
So Ram just put a clarification for Shivesh over here. Is it like a normal EC2 machine, or does it come with some pre-installed tool like Docker or something on top of that?
Yeah, it will. We have a managed Docker image, which is provided by the AWS. So if we are configuring the EC2 instance as a launch type for the ECS service, it will have that configured environment inside that EC2 instances.
Okay, got it.
Okay. Any other questions from anybody? Like, have any questions, any doubt, or any kind of terms that Ram just said regarding with respect to that architecture, maybe? No? All right, Ram, let's deep dive into the implementation now.
Okay. So if I talk about here, so here we have our GitHub repository. So you can see like this is our GitHub repository where we'll be having a couple of.
It's just zoom your screen. It's like too small for me. Just try to zoom it a bit.
Oh.
Yeah, because you're using a wide monitor. So yeah, let's zoom it a bit.
Okay.
Think,
is it visible now?
I think it will be better for them. Let us know, guys, if you are unable to see it properly. But it's good. Then we can proceed. Ram, zoom a little bit more.
Okay.
We got a comment.
How about now?
Yeah. Also, guys, this is run from Ram's side. Also, in Teams, you get an option under Views from where you can zoom it, like move it to full screen mode. So that will help you more. Yep, I think it's good, Ram. We can move forward.
Okay. So here we have already configured a repository where we have our application, which is a sample node application. And here we have our Docker file, and we have a build spec.yaml file. Don't worry, I will explain you later, like what this build spec.yaml file does. But let's first let me quickly explain you like what Docker file is doing here. So if I clone this website, this repository, so here I can see my Docker file here. Okay. So this is the application. Let me just quickly show you that. It's a sample node application, and it will be having a static index.html file and package.json. So if we talk about this,
just zoom your VS Code as well. Like just make sure, like whenever you are representing, yeah, just zoom everything whatever you represent. Yep, good.
Okay, it's good. Okay. So let's understand this Docker file first. Okay, just quickly. So I'm taking a base image as a node Alpine. Okay. And after that, I'll be setting it, creating a work directory of a node app. Okay, it is just a working directory where I'll be performing all the, let's say like commands and all. So I'll copy all the things from my local system to this image. And after that, I will just install all the dependencies. As you already are aware, like most of you have already created some node applications. So generally for installing the dependencies, we use npm install, right? And here we need to mention like on which port will be like deploying our application or like running our application. So for us, like it will be port 3000. Then entry point is more sort of like when we deploy a container, right? There should be a command which need to be run at the when we initialize the container, right? So this is the command which is node app.js, which we can also say npm run or npm start. So this is the command which will be run when our container is initialized for the first time. So when this image is like copied inside a container, so it will be already having our binary files, right? So when we run this npm start command or this node app.js command, it will automatically run our application on that particular container. So if I talk about this build spec.yaml file, Let's close this. So here we have like basically we are using version 0.2. It's the latest version. And inside buildspec.yaml file, we have phases. So the first phase is the pre-build phase. So before building, running the build command, there are some dependencies that we need to resolve. So here, like what I'm doing is like we have Amazon ECR repository. So for that, we need to first log in inside the repository before we can work with it. So here I've just put it a command which will log in inside your private container registry. And I have just put it some URI of the repository. And also I have added the tags here. For tagging part, I will just explain you here like why the tagging is necessary. Now let's come to the build phase. So inside build phase, we'll be building our application. Now we'll be leveraging our Docker file for that. So if you see the command here, we have for building the application, we have Docker build -t. -t represents the tag path. So I'm just taking the tag from this variable, which is this URI, and it will tag it as a latest one. So dot represents like my Docker file is present in the root directory only. So this is the command. And after once my repository is built, I will tag it with another tag, which will be this commit hash. So whenever like I am pushing my code to code repository, it will suddenly create a commit, right? So when we like having a lot of container images, right? It's difficult to mention like which one is like having exact changes. So we track them with the help of this commit hash. So I've also like created a tag with this using this commit hash. So we'll be having two tags. One will be our latest one, and another one will be this commit one. Okay, commit hash one. So once I come to this post build image, so once we have our image ready, right? Now we need to push it inside our ECR. So for that, like we'll be have this Docker push command where we'll be pushing our this images, container images to that ECR, right? So once like we have pushed that, we need to create a artifact sort of thing. It's not like a zip file, but we'll create a file which will be referencing the name of our application and like this container image. And inside that, we'll create a image definition.json file. So this image definition.json file will be referenced by CodeDeploy at the time when we're deploying our application, right? So inside the artifacts, you can see like for the files, I have just outputted image definitions.json. So once we have our build project ready, and as an output, we'll be getting image definition.json file. Okay. So that was all about this application code part. So let's quickly jump towards our inside our console and let's implement the project. Okay. So firstly, we'll be creating a ECR repository. So if I open ECR here, we need to create a repository.
Yeah, before you move on creating a private repository, right? Let's ask like anybody have the questions around the file that you showed with them on the VS Code side. So anyone, any questions around the code that Ram showed in the VS Code and you are unable to understand that? I know it's hard to understand each line of the code, but if you are not able to understand overall the structure of the repository, let us know in the comments for that. All right, Ram, okay, let me just take it over from here. So Ram, you want to go back to your VS Code?
Okay.
All right, so just zoom a bit, like on the left-hand side, just zoom a bit more.
Okay.
Yep, better. All right. So the thing is, whenever, let's say, being as a full stack developer, being as a developer only, right, you will be using some frameworks, right, to write your code. It can be, let's say, Node. It can be, let's say, React, or it can be, let's say, .NET, right? It can be, let's say, Java. So you will be using some framework to write that code. So here we are using a Node code. So here you can see app.js and index.html and package.json in the left-hand side, which will just build your application, nothing extra in that. So what being as a developer, what generally developers do is they just compile the code, they get the output file, and they host their application, which you see live, right? But what we're going to do over here is we are going to use the modern approach where actually we are going to containerize this application. Now, when we say containerize, what does mean is, so if you have heard a word Docker in the market, right? What that tool do is it basically combines your software dependencies and application code together to run that application exactly the same on any platform. Doesn't matter where that server or that particular environment will be. It will run exactly same on Linux, Windows, or Mac. It just needs that particular Docker system to be installed on top of that. That's why we are using Docker approach over there. And whenever you use Docker, you have to create a Docker file in which you define the sort of step using which your running application will be ready in a form of image. Okay. Now, when you get that image, you need two platforms. One, a place where that image will be stored, and another platform where that image will be deployed to keep it running. Like similarly, how you store your code in the GitHub. So here, for storing that Docker image, which you got created, either you can use Docker Hub, but in this session, we are going to use ECR. Clear? Now to run that, either you can use a VM, and here in this tutorial, we are going to use ECS Fargate service. That's the motive of this session. Now, one more file that got left in this code is build.spec.yaml. This entire approach, you are going to see through the CICD part. You might have heard CICD in DevOps. This is what exactly you're going to see over here. That as soon as developer will make a change into the code, something will automatically running. That's called as the pipeline. Your image will be getting ready automatically with a new version, let's say 1, 2, or 3. And that's how it will get posted on the ECS Fargate service. That's the end of the goal that we're going to achieve after this session. So what we're going to do is we will deploy the infrastructure now for this particular scenario to get completed. And this particular file he will be using to perform all these steps to compile your Docker file and get the image and push it to the ECR. I hope that makes sense now. Perfect. Ram, back to you.
Okay. So here we are inside Amazon ECR, and we'll be creating a private repository for it. So I will just give it a name, registry webinar 01. Okay. Basically, like this is the standard best practice which we follow inside industry, and this is a standard naming convention. And let's come towards the next image tag immutability. So you can either create your tags mutable, which can override, let's say like you are using latest tag, right? So your next push, which will be creating like, let's say like you are creating a new container image. So that will be overwritten that override that latest tag, and that will be your new image. So we'll just enable this option. Then for encryption, I will just leave it as a default, and I'll just create a private repository. So we have just created our private container repository where we'll be storing our Docker images. Next, I will just be creating a CodeBuild project. So this is the CodeBuild console, and here you can see a developer tools. So all the DevOps related tools, like generally which we do for CI/CD, let's say artifacts, source code commit, code build, and code deploy, code pipeline are present inside this particular console. Okay, so let's start with the code build part. So for code build, we need to create a project first. So for configuring the project, I will just give it a name. Let's say build. Okay, and for source, we can add GitHub. Okay, now inside the GitHub, I already have my GitHub connected to with this code build. But let's say if you are doing for the first time, it can ask you for authentication, and it will provide the access to it. Okay. Now, if I talk about the repository part, so if you drop down and if your GitHub is already connected to it, you will already able to see all the repository inside here. Okay. So we have our repo webinar here. So I will just select it. Then for additional configuration, we don't need anything right now. Okay. And for webhooks also, like we'll be using code pipeline. So we don't need to implement webhook events. Basically, like what webhook will do, Like once your code has been pushed inside your GitHub, it will automatically trigger your code build and it will generate a build for you. But we'll be using code pipeline. So I think like we don't need it. Okay, so let's come towards the environment part. So this is where your code build project will return. Okay, so you have two provisioning models. Either you can go with the on-demand or the reserve capacity. Reserve capacity is more sort of like if you are already having a fleet of EC2 instances and you want to run your code build project there, so you can choose reserve capacity. But as like we don't have anything like pre-installed or like previously configured, so we'll go with the on-demand thing. Okay. Now, if we talk about the environment image, like what is the operating system and like which is the default dependencies that we want in our system. So there are two options. Either you can go with your custom image, which is a Docker image, and it will be configured on your system, or you can just have the managed image, which is managed by AWS CodeBuild. Next, if I come towards the compute, again, you have two options. You can go with the EC2 instance if you want that server approach. And second option is AWS Lambda. Now, the benefits of Lambda can be like you can get faster builds, okay, and slower setup time because when you need your EC2 instance, it took some time to run the user data and all. So it can be a bit time consuming, but EC2 instances are more preferable if you have large build, right? Because in Lambda, we have a limitation. It can only, it has a runtime of 15 minutes only, right? So that's why like we'll go with the EC2 only. Then for operating system, just choose Amazon Linux and runtime will be standard. Now for image, you need to choose the latest one, okay? Currently it's 5.2, Amazon Linux 5.2, but in future if it's 6.2, so make sure like you're always choosing the latest image only. Now, next thing is like it will create a new service role for you. We'll be creating a role because, as I previously mentioned, like in AWS, like if one service needs to talk to another service, we need a role. So what this role will be doing, it will be assigning permissions to code build to talk to different services. Let's say CloudWatch logs, because we'll be pushing our build logs to CloudWatch also, right? And Amazon S3, because it will be publishing its artifact inside S3. So here we create a new service role, and if you already have existing one, so you can select here also. But for now, let's go with the existing one only. Now, let's say like if I drop down the additional configurations, we have a timeout option. Let's say like you don't want your build to run more than 1 hour or like half an hour, so you can mention here. Then this thing we don't take, and also like if you want to run code build project inside of VPC inside a secure environment. So here you can just select your own VPC and run code build project inside your own VPC. But for now, we'll just leave it as it is. Then for environment variables, let me show you here. If you see in our build spec.yaml file, we have some environment variables like AWS default region, AWS account ID, which will be directly passed from our code build console to our build spec.yaml file. So what I'll do, I'll just quickly copy this here. And if I go back to console, let me just quickly paste it. And if you're here, you can just see like which region we are using. So we are currently in US East 1. So let me just type it here. Then next environment variable we are having is this AWS account ID. Now to get your AWS account ID, what you can do on the right top corner, if you are click on your name, and inside that you will just able to find your account ID. So just copy this 12-digit number and just paste it here. Now the last environment variable is this repository name. Okay, so it can be here your image report name. Now for the image repo name, let's head back to the ECR, and from here you can just directly copy your repository name. Okay, so we have configured the environment variables. Now let's come towards your build spec YAML file. So either you can directly insert your commands here in the editor, or you can use the build spec.yaml file. Okay, so we'll be using it, and by default, it will look in your root directory for this build spec.yaml file. But let's say like if you are using it with some other name, or like it's located in some different folder inside your repository, so that path you can mention, just mention it here. Okay. Now, for artifacts, we'll not be needing any artifacts because we are already pushing our image to Amazon ECR. But in traditional cases, let's say if we were not using Docker, so in that case, we will be needing an artifact which we need to deploy it on, let's say, EC2 or Lambda. Okay. Now, for logs, we'll be using CloudWatch logs. Okay. Basically, it's optional, but as a DevOps engineer, it's a best practice to implement logs, because whenever you trigger any error or something like that, so logs are the first thing where we look to troubleshoot that particular error. Okay, so I'll just give it a name, logs dot build dot pattern. Okay, and I think we can go to create a build project. Okay, so our project has been successfully created, and here you can see like our source provider is GitHub, and our repository is repo -mapinar-01, and this is our service role. Now, just a quick thing. If I start a build now, it will fail. The reason behind it is like, let me show you the service role here. So this is the role which was automatically created when we created the CodeBuild project. Now, by default, it has two policies. First policy is giving it access to CloudWatch logs, where it will be pushing its build logs to CloudWatch. And the second is the base policy, which is used for the code build. Now, basically, like CodeBuild needs access to Amazon S3 and CloudWatch logs only. Okay, so these are the default permissions provided to it. But we also need CodeBuild to talk to our ECR repository, right? Because it will be building our image and pushing it to the ECR. So for that, we need to attach another policy here. Let me just quickly open it here. And we'll attach an inline policy. So if you go to here, let's just select the JSON editor, and I will remove everything. And I already have my policies here. So let's just copy this. Now, what basically this policy will be doing, it will be giving the permissions to CodeBuild to, like, say, list the image and push our container image to Amazon ECR. So if I go here, so I will just paste my policy inside the policy editor, and I'll just create this policy. Now I just need to give a name, so I will just give CodeBuild. Okay, so I think we are good. Now let's create the policy. So the policy has been created. So let's just quickly go towards our build project, and let's quickly test it. Now the logs which I was talking about is here. Now from here, you can just test all of your logs, like what's happening inside your build environment. So it may take a few minutes to get started. Now, if you see, it has successfully logged in inside our ECR registry. And if you see, like it's giving you every information. Let's say like what's happening. It's building an image. Then after that, it's running npm install and everything, right? So here, if you see, like it's once our image has been created, it enter your post build page, and here, if you see, it just created an artifact with the name of image definition.file. I already mentioned inside a build.spec.yaml file, right? So yeah, this is our logs. So means like CodeBuild project has been succeeded. Now the next step will be we need to create a ECS service where we'll be deploying our container image. Okay, so let's quickly go to ECS.
You wanna show them, Ram, like how the image got stored inside ECR?
Okay. So here,
Yeah.
if you see our ECR repository, so
Yeah.
you'll be able to see our image. Okay. As I previously mentioned, like there are two tags. The first one is the latest one, and another is the commit one. Okay. So yeah, this is the image, and just check it here. Okay, and the size of it and URI and all. Okay. So yeah, let's quickly go back to our ECS container service. So for this, first we'll need to create a cluster. So I'll just click on create cluster. For cluster name, I will just give ECS. Now for infrastructure side, we'll be selecting AWS Fargate. And for monitoring, we don't need anything. So let's just create the cluster. Now it may take around a minute or two for the cluster to be get set up. So in the meantime, like if you have any questions, you can directly ask in the chat. Okay.
Ram, you can take a look in the chat, and yeah, people are asking the questions over there.
Okay.
I have it answered. If you wanna add anything, go for it. And also, like if anybody wants to unmute themselves and wanna ask the question, go for it, please.
Okay. So the first question I can see is so it's Ayushi, right? Ayushi asked like CodeBuild is used to build container out of images. No, the CodeBuild will be used to create the container image. Okay. So we'll be creating the image, and once that image is created, we'll be pushing it to our ECR. So that's all thing will be happening inside the CodeBuild. Okay. Okay. I think that's all the questions. So our cluster has also been created. So the next thing we'll be creating is the task definition. Okay. Task definition is more sort of a template for deciding our like group of containers and like on which port and all the environment things. So for that, we need to create a task definition. So I will just give it a name. Task. Okay. So for the launch type, I will just keep it as a AWS Fargate only. And for task size, you can select 0.5 PCPs and let's say 1 GB of RAM. Okay, so I think this is good. Now we have two options here. For one is for using the task rule, and another one is for providing the task execution rule. So this can be created by default if you don't have it, but for task rule, you need to assign it. Okay. Now, let's say like if you're creating this task definition for the first time, you won't be able to see this task execution rule here. So basically the difference between this task role and task execution role is task execution role provides access to your particular, let's say, ECS agent, which is present inside your container, to push the logs and other things to the your, let's say, CloudWatch logs, or let's talk to the S3. But what task rule is doing, task rule will give your container access to communicate with different services. So make sure like you understand this properly, okay? So I've just assigned the role here. Now, when it's come to the container, we need to give the details here, okay? So for container image URI, let's go back to our ECR, okay? And go to repository. So this is our image here. This is our repository URI. So I'll just copy it and I'll just paste it here. Okay. Now for the name, I will just give it a repository name only. Okay. Next thing is like I need to implement the port mapping. Port mapping is sort of like we need to mention like which port our container can communicate with each other, right? So for this, like we'll be using port 3000 because that's where our node application is deployed, or port name. I'll just give the container port. Rest, I think looks good. Okay, so this is good. So I'll just create a task definition here. Okay, so once the task definition is been created, so the next thing which we need to do is to create a service out of it. So let me just quickly go back and show you the architecture. Okay, so here if you see the architecture, here is our task definition. So we create a service out of this task definition. So what service do we doing? Service will be deploying a set of tasks, okay? And the task will be based on this task definition, which we just mentioned here. So inside the task definition, we mentioned like which is the repository, which is the image which we'll be using, and which is the port we'll be using, right? So this thing is mentioned inside the task definition, and based on that, we'll be deploying this service container. Okay. So let's quickly go back here. So what I'll do.
And also like just to add, if you can go back to the architecture. So if you're looking at the architecture, right, we started from number 1, which was GitHub. We completed 2, which was pushing that to the ACR via CodeBuild service, which is number 3, right? And after that, we have created our ECS Fargate service, right? Now, finally, we are about to understage CodeDeploy, which will eventually will host that Docker image from our ECR over this particular cluster service, which Ram is currently showing you. So be with on all the steps that you're following so that you know what exactly each step is doing throughout this project.
Okay. So let's create a service out of this task definition. So if I go to deploy and create a service. So here, we need to select a cluster. So this is the only cluster which we are having. So it's by default in here. Then we need to select the compute configuration here. So I'll just select a launch type. And inside the launch type, we'll be having 2 options. Here, either we have Fargate or EC2. External is more sort of like if you are having a on-premise instance or some other machine, so we can use it. But generally, we have this Fargate and EC2 only. Okay, so let's select the Fargate option. And inside the application type, we have service. And let's just give a service a name. Okay, so for the desired task, I will just keep it as a 1 only. Then for that part, you need to do just one thing, okay? You need to create a new security group, but because currently if you see, only the default one is attached, and default doesn't allow any inbound or outbound traffic, but we need to communicate to our containers at a particular port, right? So what I will do, I will just add 2 ports here. First will be the HTTP one, and for this, I will just add anywhere. And another rule is where we'll be talking to our container, right? So let me just use this custom TCP. And here I will just insert port 3000, and traffic can come from anywhere, okay? Basically, I added this port because this is where we'll be accessing our containers, and the security group will be attached to our task, okay? And this HTTP is necessary like if you are accessing your containers via application load balancer, okay? But for here, I've just added this 3000. So yeah, will be good on this side. Now make sure like you have checked this option, which is called public IP. So what we'll do, we'll just assign public IP to each of your tasks, okay? If you are using a load balancer for the ingress, so you can turn it off, but if you are not using it, so just turn it on, okay? But when we talk about as an industry perspective, so it's the best practice and like it's must to use a load balancing, okay? But currently, like we are time bounded also, so we won't be using it. But for next session, we can just plan, so use that also, okay? So yeah, let's just create a service. Now it may take a few minutes to for this to get deployed, okay? So in the meantime, like if you have any questions, you can keep that in, okay?
Go for it, Suresh.
Yeah, so I just wanna have this doubt. I wanna ask that we created a task thing, then we created a service.
Okay.
So this service thing is responsible for like uploading in the ECR in the registry.
No. The thing is like once we created the task definition, right? It's more sort of template. Okay. Now for the service, it will be deploying a group of containers, right? A set of tasks, and the task will be having a group of containers, right? Now the
Okay.
container should be having a template, right? On which like they can be built. You need to tell them like which image they need to use and on which port we can talk to them, right? So for
Hmm.
that, we created task definition, and this based on the task definition, we are creating a service. Okay. Now service is
Hmm.
nothing. It's just basically group of containers. Okay.
Okay. Okay. Got it.
Okay, so here are like services been deployed successfully. Okay, so here you can see this is our service which has been running, and the status you can see, and you can also see the number of tasks which is we are having. Okay, and you can also see like the task which has been referenced here. Okay, so basically, like based on this task definition, we just deployed a service. Okay. So this is task definition can be you can think of it as a template for this particular service, which will be having a group of containers. Okay. So all the containers will be based on this task definition. Okay. So if I show you this service, we have a task here. Okay. Now if I go to this task here. So here you'll be able to see the compute power of it. Let's say like dot five vCPUs and 1 GB of memory, which we implemented earlier, the network mode, ENI ID, subnet ID, and also the public ID. So if I just copy the public ID and just paste it here and mention the port number, which is 3000, you'll be able to see our application, which has been deployed here, right? But this is not the end. Okay. Now the thing is like we need to automate this process. Okay. Let's say whenever I'm just making some changes to this application and pushing it to my repository, it should be automatically deployed to my ECS cluster. Okay. Now to do that, we'll implement a code pipeline. Okay. So let me go back to the console and let's create a code pipeline. Okay. So here I'll just create a new pipeline. Pipeline can be pipeline. Okay. The execution mode will be queued and we'll create a new service store for this one. In advanced setting for the artifact store, we'll just leave to the default location, which is the default S3 bucket, which is created by this pipeline. Or if you need to store all your artifacts inside a custom location, so you can select this your custom S3 bucket also for encryption. Also, like we'll just go with the default AWS manage. Okay. So let's just go to next stage. So the next stage will need to add a source stage. Okay, like source stage is more sort of like from where our code is stored. Okay, it can be GitHub, Bitbucket, or anything. Okay, so here let's just select GitHub version 2. Make sure like you're selecting version 2 because the version 1 uses the old API. So this is version 2. For connection, you can just select let's say test connection. If you don't have the connection, you can just click on GitHub, connect to GitHub, and after that, you'll just need to install a AWS connector to GitHub, and it's a sort of automated process only. So it's just a 2 minute job. Okay. Next, you'll need to enter your repository name. So in our case, it will be repo webinar 01. For default branch, you just select mail. Now, to output artifact format, you can just choose the code pipeline default form or the full clone, which will be also consisting of metadata and all. But we'll just go with the default one. For trigger thing, we don't need anything for as of right now. But if you are having a custom requirement or which like let's say like you only need to deploy a pipeline when a pull request has been raised, or let's say when a push is made to a particular branch, right? So that's what we use filters for. But currently we don't need any filters. I'll just select no filter. Then next is the build provider, like the CI tool, which we'll be using for building an application. So we have already configured our code build project. Okay. So here I'll just select AWS CodeBuild. Now you need to select a project name here. Environment variables, you can also pass from here, but we have already configured inside our build project. So we are good. Okay. So let's go to next stage. Next, we come to the deploy stage. Okay. It basically refers to like at what platform you'll be deploying your application to. Okay. So if I show you the options, you have a lot of options here. Okay. Let's say if you want to deploy a cloud function template or stack sets, let's say you want to use code deploy or let's beanstalk anything. Okay. In our case, I'll just select AWS ECS. Okay. And for the cluster name, I'll just select ECS cluster, which we just created. For service name, I will just create a service -webinar for 01. For image definition file, let's say like if you need to like pass any custom file name, you can pass it here. But we have already created it through our build project, right? Because if you see our build state, that's the artifact which we are generating in our through our code build project, right? So this file will be automatically referred to our deploy state, so we don't need to mention it here. Now, if I go to next, let's just quickly review our pipeline. This is our pipeline name. This is the version. Our execution mode is queued. This is our artifact location. Basically, it's a key for our S3 bucket where our artifact will be stored. Then this is our code pipeline row. This is our source state. And currently, we don't have any trigger filter. So it's a new filter one. Then we have a build state. So we'll be using CodeBuild. This is our project name. And at last, we'll be having a deploy state. So for deploy action provider, we have Amazon ECR. This is our cluster name, service. Okay. So let's just create the pipeline. So once pipeline has been created, you cannot see like by default it has triggered the pipeline. So we are in the source state and it's already in progress, right? So it will take a couple of minutes to this pipeline to be completed. But in the meanwhile, let me just go back to my code here. So here I'm in my VS Code, and let's just quickly change our file. Okay. So here, if I go back and you can see this is we are having a green color. Okay. So let's just change the color of our web page. Okay. So if I go to my VS Code, this is index on HTML file. Okay. So this is the green color which we are using. So let's just change it to some different color. Let's say red. Okay. So this is the change which I've made. So let's just commit it in our repository. So I will just type updated. Okay. And commit changes. Now, if I go back to my pipeline, here you will see like my pipeline is triggered again. Why? Because we added a trigger like whenever we committed changes to our remote repository, it should automatically trigger the pipeline. Then once it's triggered, it should pull the changes inside this build project. It will build your application and like it will create a container image out of it and it will push it inside your ECR, which is your Elastic Container Registry. Okay. Now, once that is done, it will start deploying your application and it will deploy it to our Amazon ECS cluster. Okay. So behind the scenes, what is happening here is like it will automatically update your task definition. Okay. So if I show you here in the task definition file, you'll be able to see different revisions. Okay. So this is a second iteration of it when we created the pipeline. So once this pipeline has been completed, you will be able to see our third iteration. And based on this third iteration, our service will be updated here, okay, inside the cluster. So let's just wait for the pipeline to be completed. So we have succeeded the build state, and we have one queued execution. So here you're able to see our execution is queued. Why? Because our previous deployment is in progress. When we created the code pipeline, it automatically triggered it. So our previous one is deployed. So once completed, it will automatically make its current execution in the progress. Okay. So let's just wait for a couple of minutes. Okay. And meanwhile, if you have any further doubts, Yeah, you are open to share. Okay, so yes, I have a question here. Okay, so let's say like if you need to implement that manual approval stage, or let's say the unit testing. For that unit testing, you'll be mentioning it inside your build.spec YAML file only. Okay, like what are the tests, and that's a part of CodeBuild. So that you need to mention inside your CodeBuild project only. But if I talk about the manual approval state, so if I go to here and click on Edit, and here you can just add another stage and give it a manual approval. Add a stage. Okay. So here if I add an action curve or action provider here. So from here you can just add a manual approval. And let's say like when the manual approval has been triggered, so you can add your SNS topic here also. So which will automatically inform that the pipeline has been called for you. So first you need to approve it, and then only it will move forward. Okay. So this is how we configure the manual approval thing. Okay. Okay, so currently we are in a deployment phase for our updated index.html file. So let's just wait for a few more seconds.
Now, one thing that you will be noticing, right, while this deployment is currently going on, you might have seen like CICD, right? You might have heard about this term multiple times. This is what exactly you're seeing right now. As soon as the developer pulls the code, you just need to wait for the time to get an email that yes, your deployment has been done and your environment is ready for testing. And this is what exactly the pipeline looks like. You push your change, something happens in the background, which a DevOps engineer or cloud engineer set up. And after that, developer will get an email. And yes, he can go, or a QA member can go and can start doing that testing on the particular environment. So this is what exactly when you hear this term CICD, this is how CICD look. Okay, this is what we are doing through AWS service. Similarly, in the market, Jenkins is there, GitLab pipelines are there, Azure pipeline is there, GitHub Actions are there, Bitbucket pipeline is there, Circle CI is there, Octopus is there. There are n number of DevOps tools in the market. You can go and you can read whichever would you like, and they all do similar work.
Okay, so our pipeline has been succeeded. So let's just quickly check and see if our application has been updated or not. Okay, so I'm going to Pressure, and inside that I have inside my services. So let's just quickly copy task. So inside the task, I'll just copy the public IP address again. Now, one thing which you'll notice is your task IP has been changed. Okay, why? Because like when we updated our task definition, right, destroyed all your previous containers and deployed new containers based on the new images. Okay, so that's why like if you're able to see the public IP got changed. Okay.
Yeah, so if also do it on the second page. Okay, no issues. Yeah, so they can see the color difference. Yep.
Okay, so here you can see like our application has been updated. Okay, so that's how the things work in the real life. Okay, like whenever you push the put changes, let's say even if you are doing a small change also, okay, it will directly trigger your pipeline. Okay, and it will automatically build your image, push it into the ECR, that it will directly deploy it to the cluster. Okay, so that's the thing. So yeah, congratulations, you have successfully completed your first project. Okay. So yeah, let's go back towards our PPT here. And any questions, anyone on this side?
Yep, the floor is open for any kind of questions. If you want to speak, we can unmute you. If you have something, put in the chat. Otherwise, we will start with a quick quiz questions. And we'll use comments where you can put your answers.
Hello, sir.
Yep.
I'm audible. Sir, I want to ask that if the IP is getting changed, any method by which this can be handled, like if we can add a plastic load balancer into it, or how it will be managed, like
Yes,
if every time the IP is changed.
Okay, let me answer your question. Okay, generally like when we create a service, okay, we attach a load balancer, which is also known as ingress load balancer with it. Okay. So what it will be doing, it will be having your static DNS name, okay, through which you will be accessing your application, okay. And at the behind, it will automatically connect to all your tasks, okay. And you don't provide that public IP to all of the containers, okay. As previously, I already mentioned you, like it's the best practice to use the load balancer because by that you will get a static DNS name, okay. So yeah, you're right. We generally use load balancer only, okay. But just to showcase here, I just assigned a public IP to all the tasks, and that's how we are accessing it, okay? I hope that answer your questions, Jesh, okay?
Yes, sir, definitely.
Okay. Okay. Anyone else?
No, I think it's time for quiz. You can just show the question, Ram, and after that, let's use the comments as the place to put your answers.
Okay. So this is the first question.
So the question is, what feature of GitHub allows multiple developers to collaborate on the same project and managing changes in the code? Branching, pull requests, issues, or all of the above? All right, we'll wait for you guys to put your answers. Okay. All right, we got one response. All right, keep going, guys. All right, 1 second. Okay, it says D, A, D. All right,
Okay.
fast, guys. Just give it 3 more seconds, Ram. Let's see if
Okay.
someone wants to reply. All right, Ram, go ahead and reveal the answer now.
Okay. So yeah, is the answer of the above.
All right, the answer is D. Okay. So the reason might be, you might be thinking that it's A because yes, definitely when the developers works on the multiple things, right, together for a single project, they definitely create the branches. But at the same time, the project cannot be done, okay, like, or they cannot be merged together until the PR has not been raised. And issues is the thing for which you create the task. So, yeah, so answer is D for the first one. All right, let's go for the second now. Ram, you want to read the second question?
Okay. So second question is like in AWS IAM, what principles should you follow to ensure users only have permissions necessary for their task? So options are role-based access control, least privilege principle, MFA, or identity federation. Okay, we are getting an A, B, C.
Okay, let's give 2 more seconds, Ram.
Okay. Okay,
All right,
we have
let's
3B,
reveal.
1A, and 1D. Let's check it. It's B. Okay. So as you already know, like in IAM, it's the best practice to follow the least privilege principle, right? To provide the least permissions which are necessary. So yeah, that's the answer. So let's come towards the next one. Which AWS service automatically scales to handle multiple builds simultaneously and eliminates the need of managing build servers?
Try to answer on your behalf, guys, right? Right. So yeah, like again, right? Nowadays kids are smart. You guys are smart, right? So try not to use any kind of AI tools, right? To figure out the answer because otherwise it's of no use for yourself, right? So doesn't matter if you get wrong also, but something that you're gonna learn from here. Okay. Just again, if you're not doing it, that's great. But if you're doing it, stop it. Okay. All right.
Okay, so we have 5C. So let's just check the answer. Yep, it's a code build. Okay. So we have already seen inside our practical implementation also, like code build is used to automatically handle our build needs and it automatically scales also based on our needs. Okay. So yeah, that's the right answer. So the next question is, what is the primary purpose of AWS ECR? The options can be continuous integration and delivery, container orchestration, managed Docker container registry, version control for code. Okay, so we have C here. Let's check the answer then. Okay, it's the C only, okay? Manage Docker container registry, as we already discussed many times during our session also. ECR used to host the Docker container registries, okay? Yep, that's the right answer. Now the last question will be, AWS ECS is primarily used for what purpose? Options are storing Docker images, running and managing Docker containers, monitoring application performance, automating code deployment. Okay, we have a C, two B's, and one D. Okay, so let's check the answer. It's B. Okay, so basically, like I think for the ones who answer C and D, for monitoring application performance, we use CloudWatch. Okay, we store the logs, and that's how we monitor the performance of it. And the one, so D, for automating code deployment, we already use the code pipeline, right? So that's how we are automating the deployment of application. For ECS, we already see like it's used for managing our Docker containers. So the right answer was B, okay? So I think, yeah, good. For the session summary, like we follow the best practice for storing our code on GitHub with the help of private repositories. Then we created a fault-tolerant and lightweight environment using ECS as it's a microservice architecture. And as we also know that containers are more lightweight as compared to your VMs, which are EC2 instances, okay? Now, for storing container, we used a private container registry and provided secure access to CodeBuild also using IAM. Then we created an automated deployment process using code pipeline, GitHub, CodeBuild, and CodeDeploy. And at last, we also implemented logging also, if you remember, by using CloudWatch logs, right? So yeah, that's our session summary for you. So yeah, thank you for joining the session. Okay. And hope to see you in the next slide, okay?
All right. Thank you, Ram, for providing like insights, right? And like on the session, and hope all the candidates got right, like a deep understanding of how these things works in the reality, and how when they again these like currently you're in the college, but when you will join an IT company, right, you'll be seeing that those things is the reality which you have just seen now. So yeah, like and again, we will be keep doing this, not maybe often, but maybe by like as soon as again as I said, as per the time slots, as per the availability. So you can be in the touch, right? And also I'm just sharing a form link in the chat. Okay. So this is a open form link which you guys can go ahead and you can start fill it out. And you can just also save it if you're not filling it at the moment. It just have some couple of questions. So this will at least ensure us like what actually you got out of this session, right? And will again will help us to understand from your perspective what exactly you guys are looking for. Maybe you need a basic sessions, a bit more advanced sessions, some more in a different way, maybe a bit more on the practical side. It can be anything, right? So it has some maybe some requests from your side, any kind of inputs or suggestions. So go for it and you can start filling out this form. Okay. And so that before we take the next session, we'll make sure that these things are already being taken care of. Now, apart from that, just another thing from my side is I'm also sharing you our other social media account references. Okay. So you guys can get in touch over there. Like we have started posting some cheat sheets over there for your better understanding, for better learning. So this can be your notes that how you use in your exams. So it's the same sort of cheat sheets that you guys can refer to. We also started posting the quiz over there. So that will enhance your IT and the DevOps technical knowledges on the development side or the cloud or the security side. So you can stay connected over there. You can stay tuned with any kind of future updates. And yep, see you guys in the next session. Nothing much from my side. Any other thing or any last thing or anyone? So we can just take a look. Anything from your side, Ram?
No, sir, I think we are good.
All right. Okay. Yeah, I don't see any other further things. That case, I wish you all the best. Keep learning. Yep, got it, Yash. And keep learning, keep growing, and yep, stay in touch and see you guys in future sessions. Take care, have a wonderful day, and take care. Thank you. Thank you for your time.
Thank you, guys. Bye.